So today we're going to look at the ENSA final skills exam, the final packet tracer exam, through which we're going to test our skills on what we've learned on the enterprise networking and security automation. So I'll click and I'm going to take assessment, and I'm using the latest version of packet tracer. Okay, so I'll just wait, then open packet tracer executable. I'll give it some time so that it can load, and we'll begin from that point. Okay, so we're going to start assessment. And give it some time so that the packet tracer file can be loaded to our packet tracer application. Okay, so I'll open packet tracer. So this is the task. Okay, so we have the topology and the instructions on the left side, and the physical diagram on the right, and I'll go through the instruction so that we can begin the task. So yes, the addressing table, and as you can see, we have several interfaces that we need to configure. And now we go to the instruction. I'll just read through the instruction very fast then. Okay, so we may begin. In this packet tracer, you will configure devices in a small network. You will complete all tasks in physical mode. You will not have access to logical topology. You will place devices in proper locations and power them on. You will configure routers, switches, PCs to support IPv4 for hosts. The routers and the switches must be managed securely. You will configure OSPF version 2, NAT and access control list, and then further we are required to back up the working configuration to FTP server and upload a working configuration to another device. Okay, so device version of image are used in switches. You will update switch to use the latest version. It's fine. Alright, so let's begin. Place devices in proper location and connect them with the proper cables. Alright, so step 1, place devices in proper location inside the wiring closet. Alright, okay, alright. Okay, so we have a physical mode here on the right, and as you can see, the devices have been placed on the shelf. And when you move to the right, you see an empty rack here, this one, and the cables on either sides. Then if you move down, you will see tables, table 1 and table 2. So if I try to zoom out, you can see it better. We see the devices on the shelf, and the rack here, and the 2 tables, and finally the cables. So guys, I'll start just reading the statement and see what to do. Organize the rack for ease configuration. Place router 1, router 2, switch 1, 2, 3 and 4 from top down with some space between the devices. So we are being asked to place router 1, 2, then switches 1, 2, 3, 4 on the rack here. On which order? Top to down, and we should leave some spaces in between the devices. So I'll just proceed very fast so that we save time. What I'll do, guys, we can't identify which router is router 1 and router 2 here. So what you do, maximize here, maximize again. Okay, so, and I'll just a little bit do this. Okay, so as you can see now here, we can identify which router is router 1 and which router is router 2. And as you can see here, we have router 1 and router 2, meaning router 1 is the one on top and router 2 is the one below. Okay, switch 1 and switch 2, switch 3 and switch 4, and we have router 3 and router 2 here. Okay, and then we move down here. This is switch 0 on top and multi-layer switch 0 bottom, and this is multi-layer switch 1. Okay, then we go down. This is PCC. Then we have Meraki server on top and DNS server here, and finally we have the two PCs here, PCA and PCB. Okay, so what I'll do, I just try to minimize again so that we can proceed. Now that we have identified that which devices are these, now we can begin placing them on the rack, and we've been told to use top down. Okay, so we'll start from router 1, then router 2. So guys, we're going to start drag to 43 31 routers R1 and R2 from the shelf to the rack. So guys, as we saw earlier, we said these are our R1 and R2. Okay, so we'll just drag them. So R1 was above and R2 was down, R2 was below it. What I'll do is just to do this to see. Again, I'm zoom out, so as you can see, R1 and R2. Okay, and we've been told to use top down, so we start from R1 to down, then we proceed to switches. We go to switch 1, 2, 3 and 4, and if I try to minimize, if I try to zoom in now, you can see that this is switch 1, switch 2, switch 3 and switch 4. So they are in order, and if they are not in order, you are required to place them. So for example, we start from switch 1 here, then switch 2, then switch 3, and finally switch 4. Okay, and now we proceed to the next step, which is about the PCs. Move PC to tablet 1 on the left, move PC to table 1 on the left and place it on the left hand area of the tabletop. So PCC, I'll just zoom in again. PCC is this one, as you can see, this is PCC. So it's required to be moved to table 1, and this is table 1. So I'll just do it very fast, just that way, and then okay, move DNS server to table 1 on the left. Okay, the left, place it left hand area, and for the DNS server we are going to place it on the right hand area. So this is the table, this is the left hand, and this is the right hand. So we're going to drag DNS server and place it on the other side. So let me maximize again, zoom in, so this is the DNS server, the one below. So I'll just drag it and place this one here. This is Meraki server and this is DNS server. Then zoom out and I put it here. Okay, it's very easy. And then finally move PCA to table 2 on the right, place it in the left hand area of the tabletop. Okay, so PCA, I'll just try to check on PCA among the remaining. This is PCA and this is PCB. So what I'll do, okay, so move PCA to the right, to place on the right hand table, to place on the table on the right, then in the left hand area. So PCA will stay here, while PCB will stay on the other side. Okay, no problem. So guys, we are done with that part. So the part that is remaining is to connect the devices. I've zoomed out. Okay, so to connect the devices, guys, we are going to reference on the topology here that we've been given here. Okay, it's very simple. It's very simple. So we need to reference on this topology here. Okay, so that's enough. Right, so we can start with the routers. As you can see, we'll use a link between the two routers, and the link will be connected to gig 000 on the both routers. And remember, these are router to router, and for the same devices we use a crossover cable. So guys, let's go here. Let's go here and select this crossover cable. Yes, so that's the crossover cable, and we need to connect it to a gig 00 of router 1 to gig 00 of router 2. So just zoom in so that they can be seen. Okay, so here are the routers that we have. Zoom in again. Okay, so this is router 1 and this is router 2, and we've been asked to connect the devices. Okay, so what I'll do, I'll just check that which interface is gig 00. As you can see, that is gig 00. I place that cable there. Then I come to router 2, which is gig 00, and I place the cable there. So guys, as you can see, we have a crossover cable connecting gig 00 to gig 00 of the two routers. Okay, so let's proceed again. Now let's start from router 1 to switch 1. Okay, so router 1 to switch 1, we are going to use a copper straight through. Okay, we are going to use copper straight through because the router to switch we use copper straight through. Take that one. Okay, so we use which port on router 1? We use gig 002 to gig 01 of switch 1. So let's go to router 1, which we check which port, gig 002, that one, right? I click on that one. Then I move to switch 1, which is this one. Then you connect it to which port? Gig 01. Okay, that's first Ethernet. First Ethernet. That's the gig 01. Okay, you connect it there. So guys, if I hover over this cable, and you will see it's a crossover cable connecting router 1 through 001 to switch 1 through gig 01. Okay, so we proceed to, let me do this again, just a minute. Okay, and a little bit of this side. Okay, alright, so we take it from router 1 to switch 2. Okay, router 1 to switch 2, connect from router 1 001 to switch 2 01. So I still choose a crossover cable, just this one, copper crossover, I mean straight through, sorry. We take a straight through cable, then you connect to router 1 001. Okay, that one. Just try to hover, and when you see a pop-up like that, just click. Alright, now it's clicked. Then we go to switch 2, we connect it gig 01, this one, right? Click that way and try to hover over this cable, and you will see it's connecting router 1 from 001 to switch 2 01. Okay, alright, so guys, let's connect router 2 to switch 3 and switch 4. So I'll do that one very fast. Make sure to zoom in so that the devices can become larger. Okay, alright, so I'll take this one, connect a switch to a router. We use straight through cable. Then if you need to connect router to router, use copper crossover. So we connect router 2 to switch 3, router 2 002 to switch 3 01. So router 2 002, that one, that interface, can you see it? I click, then I move to switch 3 001 I mean gig 01. So this is switch 3 and that is interface is gig 01. I click that, but it's like I never clicked on the upper interface of the router 2, so I'll do it again, which is this one. Just a minute, that one, I click it there. Okay, alright, so if I try to over this cable, you will see it's connecting switch 3 gig 01 to router 2 gig 002, right? So let's connect router 2 to switch 4, router 2 to switch 4 001 to 01. Okay, I take again straight through cable. We come to router 2 001 now. Just hover until you find the 001. Just try to hover until you find 001, that one. And sorry, just a minute, that one. Then I click. Is it really clicked? Yeah, let me just do it again. Okay, so let me try on switch 4 001, this one, this interface. So it's not clicked above, so I'll just go up and again and try it. So just make sure it's accurate, that port. Okay, now it's clicked. Hover over it, you will see it's connected to switch 4 01 to router 2 001. Okay, so let's make connection between switches and the PCs. Okay, that is very easy. I'll try to zoom out a little bit. Okay, sorry, not the computers on the right side. Let's just start from PCA. So PCA is on this side. PCA is connected to switch 1. So we just take straight through cable and we connect to a first Ethernet port of this PCA, then to switch 1 FA05. So FA05 is somewhere here. Just a minute. FA05, that one, and you click that way. Hover over it, you'll see it's connected to PCA, first Ethernet 0, switch 1 FA0/5. Is it 5 or 6? It's 5, I believe. Yeah, it's 5. Then you connect PCB to switch 2. This is PCB. We just take straight through cable to first Ethernet 0 to switch 2 FA0/5. Same. That port. Then I hover over it. PCB first Ethernet 0, switch 2, first Ethernet 05. Good. So I move on the left side and do the NAT configuration. The DNS server is connected to switch 3 through FA0/10. So I'll do that one very fast. I'll take a straight through cable. Then I move to the DNS server. I click the port. Then we move to switch 3. Switch 3 is this one. Which port? FA0/10. I'll just try to locate where the port is. That one, right? Okay, move over the cable, see the information, DNS server switch 3 FA0/10, and finally we connect PCC to switch 4, through which interface FA0/10. Okay, so I take this cable here, just click on it, then you connect here. You connect here until it turns green, then you come to switch 4 FA0/10. Just a minute, that interface, right? And I click, see the information, everything is connected as expected. So zoom out, so everything is connected as expected. So I'll proceed with the instruction. Okay, so step 2, make sure all the devices are powered on. How do you ensure that? Let me try to click on PC. All usable tabs are hidden or locked, they will remain closed. Okay, alright, so let me just zoom in again. And zoom in again. There's just one thing that I want to show you on the PCs. Yes, so as you can see guys, this PC is shut down. It's not powered on. You see the button is here and the button has not been powered on. Okay, so what to do, just click on it, and as you can see now it is green. Okay, so let me just move left, and the server also, just click there, see changes, then you come to this PC also, click it, you see changes now, and finally you click and you see changes. Okay, and let's check the routers, but the switches don't have any button. Now we proceed directly to the routers. For the routers, I'll maximize again. Do they really have button on these sides? I'll try to maximize again to check if they really have buttons on this side. Okay, just a minute. Okay, just a minute. Inspect rear. Okay, just a minute. What I'll do, I'll just try to check if the routers are also powered on. If they are not powered on, then I'll do them. Let me just click. The device is locked. Okay, inspect rear. Okay, just a minute. The routers are or not. Just a minute. Let me just maximize again. It's quite challenging. I'll just do this. Okay, so inspect rear. Okay, so the router is on. Also this one, inspect rear, and you click on, there's something like a 0, 1, 0 and a minus. Just click on the 0 and close, and now the router is on. Okay, I believe the routers are on, and I've just done the right thing. And for the switches, they're always on. Okay, alright, so what I'll do is very simple. I just zoom out again and proceed to step 3. Connect devices according to the topology. Use logical diagram to connect the devices to the correct port with the correct cables. We've just done that. So we move to part 2, which is to configure basic device settings. Okay, alright. So for part 2, configure PCs with IPv4 addresses. Okay, so we need to configure the PCs with the IPv4 addresses. We'll use the addressing table here. Okay, we'll use the addressing table here. Let's start with PCC. This is PCC, and PCC, the IP address is IP address is this one. Just a minute. Okay, that's the IP address, which is 172.16.2.5, subnet mask of 255/24 notation. Okay, then default gateway will be 172.16.2, 172.16.2.1. okay, and DNS server is this one. I'll just copy. DNS server is this one. The IP address of DNS server is this one. Yes, IP address of DNS server is that one. So I'll just click again and paste this one there. And now we've configured PCC IP address. So let's move to PC A and B. I'll click on PC A IP address, then paste the DNS. Okay, so we move to IP address, which is this one. Copy and I paste here. Sorry. Okay, now subnet mask will be /29 notation. /29 notation is equivalent to, let me just calculate very fast. It's 255.255.255.248. okay, alright, and the default gateway is this one. Okay, so we paste that, and let me copy the DNS server. I close, then we take this one, PCB, and we paste the DNS server. Okay, alright, so we come back here and take IP address of PCB, and just a minute, subnet mask that one, as you can see here, /24 notation, and this is default gateway. So that's done. Okay, so let's move to the next step, which is to just a minute. So we've been told that all the configurations are made through direct console connection. Very important. So configure router 1 and router 2 with the following. So before that guys, what I'll do, I'll be using this PC to access these devices, the routers, through console port. So we just take console cable, here, and let me zoom in just a minute. Then you come to PC here, you place it on RS232. After taking console cable, place it there. Then we go to router 1. We start from router 1, this one. Okay, so we check which port is console port. So I'll just try to hover until I find console port. So I'll just have to give me some time. Okay, in case I can't find the console port, then I'll just right click and say inspect rear. Okay, and check which port is console, that one, right? And I click there. Alright, so I move to PC A, PCC here. Click on PCC, then you come to terminal and leave everything the way they are and click OK. So as you can see, we have accessed the router from this PC. Just say no, enable. Alright, so we are required to configure the following. We are required to configure the following: hostname. The first thing that we need to configure is to prevent the router from attempting to resolve incorrectly entered commands. That is, what do we configure there? Config T first. No IP domain lookup. Very important and very simple. Okay, then we configure hostname to be, this is router 1, I believe, R1. Hit enter. Okay, and then encrypted privilege exec secret password. Very important. They have said encrypted exec secret password. So we just go here and say enable, secret. I paste what I've just copied. Cisco and pass. So let me confirm if there's no. Okay, Cisco and pass, and I hit enter. Then line console password should be the same as that one, so we just say line console 0. Okay, then line console password, access password to be, I just paste again and I make sure. Then authenticate the user, login, exit the interface. Alright, so encrypt, set the minimum password length to 10 character, so that when we say security passwords, min length to be 10. Okay, very simple. And encrypt the clear text password. Which command we use? Service password encryption. We hit enter. And finally configure banner MOTD. Banner MOTD. Then let's use these characters. Then inside the character, let's say no unauthorized access. Okay, all right, so guys, we are done with the first router. So let's go to the second router. Okay, so we need to transfer the console cable to router 2. How do we do it? We just right click on the first router and say inspect rear, and also come to router 2 here and inspect rear. So sorry, you remove this one, then come to, there's a problem, just give me some time. Let me put this one up a little bit. Okay, so this is our router 1. Right click, inspect rear, and this is our router 2. Right click, inspect rear. Okay, then remove this first cable and place it on a console port on the second router. Okay, so I'll try to place okay. So guys, as you can see, now the console cable has been transferred to router 2. Very simple, just simple instruction. Okay, so I'll move again to PCC and do the necessary. Okay, no, enable config. The first thing that we need to do is to disable IP domain lookup. So we say no IP domain lookup. Okay, then we give hostname to be router 2, and what else? Privilege exec mode password. So we just say enable secret, because they have said privilege exec secret password secret. Then I paste what I copied earlier. Okay, just a minute. I hit enter, and now console access password, we just say line console 0, then password the same what I've just copied, hit enter, and set the minimum password length to 10 characters. So you just say security, we've not finished on the line console 0, so we just need to authenticate the user, login, then exit the interface. Alright, sorry. Now let's configure the minimum password. Security passwords, min length to be 10, done, and encrypt all clear text password. Which command we use? Service password encryption, hit enter, and finally we need to configure banner MOTD. Then these 2 characters, inside the 2 characters just say no unauthorized access. Okay, hit enter. Alright, so we are done configuring the second router. Alright, so we move to step 2, number B, configure the interfaces of the routers, router 1 and router 2 as follows. Configure gig00 with description and IPv4. Okay, configure gig001 with description and IPv4 addressing. Configure interface of this one with description and that one. All interfaces should be ready to send and receive traffic. Very important. Okay, so what we're going to do, we have to go to the addressing table, and remember our console cable is still on the router 2, so we need to begin from router 2. So here are the interfaces of router 2. Okay, so I'll just click on this, come terminal. Okay, so we are still in router 2. So interface gig 0/0/0. Okay, then we've been asked to give the description and IPv4 address and make it ready to use. So this is the IP address. I'll copy IP add. Okay, and subnet mask of /30 notation, which is equivalent to 255.255.255.252. Okay, and let's make it ready to use. No shutdown. Okay, then description. Let's say this is R2 gig 0/0/0. Although this is not the best way to give a description, you can say this interface connects to either switch or the other router, who knows. Okay, alright, so exit this interface, then we move to gig 001 this one. Then let's give it a description first, something like that. Okay, all right. So IP address will be this one. I copy and I say IP address, I paste, and a subnet mask of 255.255.255.0/24 notation. Hit enter, and then no shutdown. Exit. Finally, gives it to 02. Let's give it a description. Okay, then IP address should be this one. Okay, IP address with that one, with the subnet mask of 255.255.255.224/27 notation. Then no shut. Okay, exit. Okay, so anything else that we can configure on router 2 before we go back to router 1? Okay, SSH. So let's do SSH for router 2 before we proceed to router 1 to configure the IP addressing and the SSH. So the first thing that we do here, we use IP domain name of sys. I'll copy this. Okay, so IP domain name, I paste that, hit enter, and then create username and password of this one. So username is admin, and a password of a secret password, sorry. So we just say username is admin, then secret admin 1pass, okay. Username admin, password which is encrypted, secret admin 1pass. Okay, all right. Set login to VTY lines. So line VTY 0 to 15. We always have 16 interfaces on the VTY line, so 0 to 15. Okay, set to local database login, local, and then login, set VTY line to access SSH only. So what do we say? Transport input SSH. Okay, and then now what do? Exit the interface. We've been asked to do what? Use a crypto key with 1024 bits modulus length. So we just say crypto key modulus, crypto key generate RSA, then you hit enter, length of 1024. Okay, and which version of SSH should we use? IP SSH version 2. All right, so we're done on switch on the router 2. We're done on the router 2, so I'll proceed to router 1 to configure IP addresses and SSH. Okay, so let me just do this, then I proceed to router 1. What do I do now? I remove the console cable from router 2, then place it into router 1. Inspect rear, then remove this cable here, place on router, inspect rear again. I've placed the wrong switch on the wrong port. Okay, so router 1 console PCC RS232. Okay, that's right. Okay, so I click again, come terminal, click OK. Okay, so what was our password? I've forgotten our password, so I'll just try to retrieve the password. Sorry. So paste that. It was Cisco pass. Sorry, Cisco this one, it's Cisco pass. Sorry, Cisco, sorry, Cisco. Okay, enable, then I paste the same. Okay, I think I made a mistake to configure a wrong password for console access. I copied the same for these two cases, and I'll make sure that I correct that now. Line console 0 password to be Cisco, so I'll copy this one. I used this one, but they're different. I thought they were the same. So it's Cisco pass. Okay, login, exit. Okay, now we can proceed to configure IP addresses to the interfaces. Alright, so what do I do? Terminal, same. Okay, so interface gig 0/0/0. We just give it a description first. Description, this interface, this is R1 gig 0/0/0. Okay, then IP address of this one, then IP address, then we paste that. A subnet mask of /30 notation, which is equal to 255.255.255.252. okay, then what else is remaining? No shut. Exit. We proceed to gig 01. We give it a description. Okay, then IP address, which is this one. IP address, a subnet mask of 255.255.255.0/24 notation, then no shutdown. Exit. Then finally to the second interface, then description. And now IP address. IP address is this one. I'll paste, and a subnet mask of /29 notation, which is equivalent to 255.255.255.248. hit enter. No shut. Okay, exit. So let's proceed to configure SSH very fast. I proceed to configure SSH very fast. Then I'll go back to the second router to correct the passwords. You know, I configure the same password for the two levels, so I'll correct it. So let's move to part C for the first router. We need to configure domain name. We configure which command? IP domain name. Let me copy this. Hit enter. Then username of admin, and the secret of admin 1 pass. Admin 1 pass, that's okay. Then we've been told to log into line VTY 0 to 15. Okay, then login local to use local database. Login local, then set VTY lines to accept SSH connections only. What do we use? Transport input SSH, then exit the interfaces, the line protocol, then we go to generate crypto key generate RSA, ambulance length of 1024. Okay, then which version of SSH? IP SSH version 2. Okay, so we're done with router 1. Guys, I'll go very fast to correct the error that I made earlier. Inspect rear. Okay, I remove this one and place here for the time being. Just a minute. Okay, so it's here. Yes, so I'll correct the password that I made. This is R2. Good. So as you can see, up, I use the same passwords. I use the same password for the 2 levels, which is wrong. So I need to re-enter a line VTY line console. Line console 0, password to be, just a minute, this one, Cisco Compass login, exit. Alright, so we may proceed very fast. Step 3, configure switches, switch 1, 2, 3 and 4. Configure hostname according to the addressing table. Configure management VLAN, set the IPv4 address and activate the interface. Configure default gateway. Guys, this is very simple. So we proceed again. So what I do, inspect rear, come to switch 1, inspect rear, remove console cable, then place on the console port of the switch. So as you can see, this console cable is connecting switch 1 and PC C. Okay, go to PCC terminal. Okay, so this is switch 1, enable config T, close a little bit. We need to configure hostname, then management VLAN and default gateway. That's very simple, guys, very simple. So what I'll do, I'll go back to the addressing table. I start from switch 1. Very simple and very interesting, you know. Just a minute. Good. So hostname is switch 1 S1. Good. And then we need to configure management VLAN interface VLAN 1. Good. Then we assign which IP address, this one. Copy IP address, a subnet mask of /29, which is 255.255.255.248. and then we need to activate that interface. No shut. Okay, and we give the default gateway. So I copy the default gateway, exit this one first, exit the interface, IP default gateway, I copy that one, then do show start. Just a minute, there's just one thing that I need to confirm. Interface VLAN 1 is okay. Okay, so that's fine. Then I move to, let me see if there's something that I need to configure before I move to step 4. Okay, nothing at all. So we can proceed to configure what I was configuring right now. Okay, so here the addressing table. So we proceed to switch to, right click, inspect area, right click, inspect area. Okay, remove this one and place there. So it's on switch 2. Good. So what I'll do, come terminal and everything is okay. Enable config T, hostname to be switch 2. Good. And then interface VLAN 1, IP address should be this one, switch 2. Good, this is switch 2. Good. IP address, that one, a separate mask of /24 notation, which is 255.255.255.0. okay, then no shutdown, exit, IP default gateway to be this one, I copy and I paste. Sorry, IP default gateway to be 192.0, I copied wrongly, 168.1.1. okay, so do show run. Okay, it's fine, it's okay. So I close that one. Then we proceed to switch 3. Just come here, inspect area, and switch 3 also, inspect area, click on switch 2, then remove it, place it there. Okay, so it's on switch 3, as you can see, switch 3 PCC. Good, it's very interesting. Terminal. Okay, enable config T, hostname to be switch 3. Okay, then interface VLAN 1, IP address to be this one, with a subnet mask of /27 notation. /27 notation is equivalent to 255.255.224. then no shutdown, exit. Guys, let me just confirm something here. Shut. Okay, so let's see, no shut. Okay, it's fine. Then IP, exit first, IP default gateway to be this one, IP default gateway to be that one, hit enter and do show run. Okay, so it's fine. I don't need to worry about anything, it's fine. So let's move very fast to switch 4, inspector here, okay, drag, place there. Then we come back to, let me move about the console cable. As you can see, switch 4, PCC, good. Move to PC terminal, okay. So enable config host name to be switch 4, good. Then interface VLAN 1, IP address to be very fast, this one be that one, and a /24 notation, which is equivalent to 255.255.255.0. then no shut, exit, then IP default gateway to be this one here. I copy and IP default gateway, I paste. Alright, do right. Okay, so guys, I think we are going at a very good speed. We are proceeding well. So we need to configure a single area OSPF. Configure a single area OSPF routing. Configure the OSPF process using process ID 1. Manually configure the router ID using 001 for this router 1 and 002 for router 2. Configure network statement for the appropriate networks on router 1 and router 2. Good. For the purpose of this assignment, you enter your network statement in the following order. Alright, okay. Alright. So, what do? We return the console cable to router 1 first. Inspect here. Console cable is on switch 4. So we drag it to console port of router 1. Okay, so we are on router 1. Okay. Click here. Terminal. So okay. And that's line console, which is Cisco Compass. So this is where we use Cisco and pass. Good. Config T. So let's move very fast. We need to use a process ID of 1. Okay, so router OSPF, make the router aware that it's using OSPF protocol with the process ID of 1. Okay, then router ID to be 0.0.0.1 here. Okay, and you hit enter. Then we advertise the networks. We've been told to use this order. For router 1, we should advertise the first network, which is gig 002 network. So I'll go to addressing table very fast. Gig 002 network for router 1. So I'll assume this was I'll assume it was 64.100.1.0. Okay, so I'll copy and replace 1 with 0. Network, that one, and there's 0, and now a wildcard mask. Remember, this is /29 notation, so the wildcard mask here is 0.0.0.7. Okay, sorry, area, we give area 0 because it was a single area OSPF here. Single area OSPF. Okay, area 0. Okay, now another network for gig 00, which was gig 00 is this one. So I'll assume the network is also starting from 0, which is right. I'm not assuming. So the network starts from 0. Another network is that one, 0, and separate mask of /30 notation. /30 notation is equal to 255.255.252. Then 255 minus 252 is 3. So wildcard mask is 0.0.0.3, area 0. Okay, exit. Another thing that we need to configure regarding OSPF, let me check. Okay, we need to adjust OSPF operations. Okay, we need to adjust OSPF operations on router 1 before we move to router 2. Configure appropriate interface to not forward OSPF packets when they are not required. Configure the reference bandwidth. Adjust the reference bandwidth to 1 gigabit. Configure OSPF network as point-to-point network. Configure LO time for 30 seconds. So guys, we need to identify which interface that doesn't need to forward OSPF updates. So I'll just use the topology here for router 1. This interface and this interface don't need to forward any OSPF updates. It's only this interface, because you know it has a neighbor here, another router, but these ones are connected to the Ethernet network, the switches. Okay, so this interface and this interface will not forward OSPF updates, so we need to configure them as passive interfaces. Okay, alright, so I'll go here and just say router OSPF 1, then I say passive interface of to be sorry let me just confirm again, gig 002 and gig 001. Okay, gig 002 and gig 001. Okay, alright, and then we need to adjust what again, let me just see again, adjust the reference bandwidth. Okay, let me just reference, just a minute, bandwidth reference and recognize command. Let me just try to remember again. Remember now, autocost, we just use autocost reference bandwidth to be 1 gigabit, but you know we need to convert into 1 Mbps, so we multiply 1000, which will become just 1000. Okay, 1 gigabit into Mbps will be 1000. Okay, hit enter. Alright, no problem. Okay, so that's done. So configure OSPF network as point-to-point. Guys, as you can analyze this topology here, this router to this router, it's a point-to-point network. You see they are directly connected to each other. Okay, so we are going to configure this interface as IP OSPF network point-to-point. Okay, alright, so that's very easy, just do it very fast. So that interface is gig 000. So interface gig 000 IP OSPF network to be point to point. Good. Hit enter. And then we've been told to use hello timer IP OSPF hello timer to be 30 seconds. Just write 30 and that's done. Exit and do right. So guys, we are done with the router 2, router 1 I mean. We can proceed to the other router. Okay, we've configured OSPF on the first router, so let's proceed to the second router. So what do? Inspect rear, then remove this one and place there. Good. And scroll, click on our PC, come terminal and okay. So the password was Cisco Pass, Cisco Pass, enable. Then this one was Cisco Pass. Good. Config T. Alright, so let's start. We configure OSPF. The first thing that we need to do, process ID. We need to make the router aware that it's using OSPF as the routing protocol with the process ID of 1. Then router ID of .0.0.0.2. Okay, then we advertise the networks. So we need to follow this order here: gig 002, then gig 00, gig 000. So we go to tables and we proceed to router 2. Okay, so this was the network. That's a IP address. So the network will be I paste this one here, and that's 0. A subnet mask. Sorry. We've been told to use. There's an order that we need to follow: gig 002 and gig 00. So the first one was gig 002, which is this one. I copy. So here the network will be, let me just try to contemplate. Here the network will be 128.128.128 gig 002, then gig 000. I believe I'm not wrong. Okay, a subnet mask of /27, which is 25. Now we use wildcard mask, and the /27 notation is equivalent to 255.255.224. Then 255 minus 224 is equivalent to 31. So 0.0.0.31. That's good. Area 0. Then another network is this one. There's another network there. Network, paste. Sorry, another network is 198.51.100.0 and the wildcard mask of 0.0.0.3 /30 notation. Then area 0. Exit. Good. We need to adjust OSPF. So configure appropriate interface that do not forward OSPF updates. So for router 2, gig 001 and gig 002 do not forward OSPF updates. Okay, so just enter router OSPF 1, then passive interface to be gig 001 and 002. Okay, alright, then configure the reference bandwidth, adjust the reference bandwidth to 1 gigabit. So we just say auto cost reference bandwidth to be 1000 MB. Okay, exit. Okay, then we point to point network. So if you consider this diagram, we will configure this interface as a point to point OSPF point to point, okay, which is gig 000. So interface gig 000 IP OSPF network to be point to point, then IP OSPF hello timer to be 30. Okay, that's great. They have formed adjacencies. So guys, as you can see, they have formed adjacency with the other router. Okay, so exit and do right. So this is my query and it's as form adjacency. Okay, so what is remaining is to configure access control list and NAT. Step 1, verify connectivity. PCB cannot visit web server. PTC cannot ping PCA. Okay, let me just do that very fast. PTC and PCA. This is PCA. I'll take the IP address. I'll take the IP address and the ping. Okay, so verify connectivity. PCB cannot visit this one, PCC cannot visit, cannot ping that one. Okay, so we've confirmed the second option. Okay, so let's summarize that. Configure static NAT. Configure static NAT on router 1 with the public IP address of this to allow PCB to access web server. This is very important. Static NAT. Okay, ACL and NAT. So guys, so what I'll do, let me check which router is connected with the console cable. It's router 2. So what I'll do, inspect rear. On the other side also inspect rear. What you do, just remove this one and sorry, I'll just do it again. Remove from auxiliary and place to console. Good. So I move back to our PC here, which is connected to router 1. So router 1 has also formed adjacency to the router 2. So enable, and the password was just a minute. The password was Cisco and pass. Do show run. I've not been asked LAN console password, so I know I'm very curious about it, but it's here. it's here, so no problem. So config we've been asked to configure static NAT. How do we configure static NAT? To allow PCB to access web server using a public address of this one. Very simple. We just need to configure a static NAT. So first of all, PCB. What's IP address of PCB? This is PC1 on this PCB. Let's take IP address of PCB. Okay, I've copied the IP address of PCB. Then we need to access web server through a public address of this one. So the IP address of this PC here, PCB, will be our inside local, but the public IP address will be inside global. Okay, right. So what I do, we configure router 1. So how do we configure static NAT? Very simple. IP static IP NAT static IP NAT source IP NAT static source and recognize command. Just a minute. IP NAT inside sorry static source static the IP address of the PCB. Then we include the inside global, which is the public IP address. Okay, very simple. IP NAT inside source static, that one, IP address of the PCB, then the public IP address that we need it to be translated into, then we hit enter. Okay, all right. So guys, let's view this topology again. PCB is connected to switch 2, then switch 2 is connected to router 1 through gig 001. So interface gig 001 IP NAT what? IP NAT inside. Okay, then again, good, IP NAT inside. So this is IP NAT inside and this interface is IP NAT outside. Okay, exit, then gig 000 IP NAT outside. Good, exit and do right. So that's done. Let's proceed to the other questions. Configure part on router 2. So we move back to router 2. Inspect here. So we move back to router 2. Okay, router 2 is here. Alright, so we need to configure part on router 2 to enable some devices on the network attached to gig 001 interface to access the interface to internet. Okay, then create a NAT pool by the name IP NAT 1 with IP address range this one, with the subnet mask this one. Create a numbered access control list 1 to allow devices with the IP range of this one through this one to access the internet through NAT. Use part to allow the range of the IP address to be shared. So interesting and challenging, you know. Okay, so what do we do? So what do? We need to configure path. We need to configure dynamic path here, because we need to create pool of some IP addresses, and those IP addresses will be shared among the devices in the network. Okay, so here is our router 2. What do? IP NAT, just a minute, pool, IP NAT pool, this one, IP NAT pool, that one. I paste and I try to query what side. Okay, starting IP address. So this is the starting IP address to this one. So I will copy and remove these two. So I copy, and what I do, I just remove these two here and leave it here. A range of this one, .142.250, and a separate mask of 224. Okay, so let me copy. I'll not copy that one, I'll type manually. Sorry, so it's IP NAT pool. It's supposed to be IP NAT 1. Good, and the range should be that one. And I said I'll remove this 2. And now what to do, just write the subnet mask. And in the case of the NAT, we use net mask, which is 255.255.255.224. hit enter. Good, we've created a pool of IP addresses that we need to use. Okay, so let's proceed to part 2. Create access control list, this one, with the IP address one through. Okay, alright, so let's bind the access list to the NAT that you created. IP NAT inside list just access list, sorry, IP inside, let me just query or go to source list 1. Okay, then bind it to the pool that you just created, this one, it's IP NAT 1. Okay, let me query again. What's next? Query IP NAT 1. Then because we are configuring path, which keyword do we use? We use overload, and we hit enter, because we are configuring path. All this here, as you can see, this one is dynamic NAT. Okay, but in this case we are configuring dynamic path, so we need to include this overload. Okay, alright. Okay, so now let's see the range of IP address that should be allowed through this access control list, list 1. Okay, so we create another access control list, access list 1, permit 172.16.2.0. okay, then the subnet mask. Now the subnet mask will be 0.0.0.15, because the subnet mask that will support 15, this number of host devices should be 255.255.240/28 notation. So the wildcard mask will be this one. Okay, 240, 255 minus 240 is this one, 15. Hit enter. And now what do we do? Very simple. Okay, so we need to identify the interface and attach it to the rules that we just created on router, this one. So guys, it's this interface that will accept the packets, the traffic from this network. So we use this interface. Okay, so we just say interface gig 0/0/1, then IP NAT inside. Anything else? Good. Inside, exit, do right. Okay, so I think we've done configuring part on router 2. So I'll just proceed to see what's next. Okay, so step 3, create a standard access control list. This one to allow only PCB to access router 1 VTY lines. Apply the ACL. Wow. So I'll copy this one. Configure access control is on router 1. So we go back to router 1 again. Inspector and inspector, and we'll remove it, place it there, then place it there. Good. So let me inspect. Okay, it's on console port. Click here, I come. Okay, so it's Cisco pass, enable Cisco and pass. Okay, config. We're going to create a named access control list. So access control list standard, access control list, we need to give it a number. A named access control list to access a VTY line. Oh, so what to do here, guys? For VTY line, IP access list standard, then we give it a name. Okay, then we hit enter. Then we've been told to use PCB only to access the VTY interface. So PCB, I will take the IP address of PCB, which is this one. Which one? Okay, we only need that OS to access the VTY line. Permit, so it's going to permit, permit what? Host. Good. Paste IP address and hit enter. Good. Then exit this interface. And now what's else? We need to apply that ACL to the VTY lines. Okay, so sorry, I never, let me enter this line first. So line VTY 0 to 15, IP access class, we use this one. Sorry, let me query, we use this one. Copy and you paste IP access class, this one. Okay, hit enter. Sorry, let me query again. In. Good. Exit, do right. So let's proceed. Also, we've been told to configure the same on switch 1. So guys, this one will do very fast, very fast. I'll do it very fast. I'll copy, I'll do it very fast. Sorry, I'll do it to switch 1. So inspect here, this is our switch 1. Inspect here, remove and place here. Okay, that's done. Come Alright, okay, enable config t, do right. Okay, so what do we need to do? IP access list standard to be that one. Okay, then permit host the IP address of PCB, which was just a minute, PCB was this one. I copy, then I come here, permit this one. Okay, then LAN VTY 0 to 15 IP access class, this one. In. Okay, good, do right. Okay, so what's remaining? Let me just go very fast. Also, step 5, we need to configure access control list on router 2 again. Okay, configure access control list on router 2. Configure a standard access control, this one, to allow only PCC to access R2 VTY interface. So this is our PC router 2, this switch 1. So I do very fast, place that one there, and everything is just fine. Click here, terminal, and okay, we are on router 2. Okay, so we need to create another standard access control list for VTY interface IP access control list standard. And how do we need to call it? This one. It's a lot of work, you know. Then permit host PCC, this one, the one that we just using. Oh, I don't want to lose some of what data that I'm using, so I'll get the IP address of PCC from this point. I'll copy and come here. Okay, and I hit enter. Then LAN VTY 0 to 15 IP access class, this one. Copy, hit enter, in. Alright, so part A is done. Exit. Part A is done. Create an extended access control list with this name to restrict access from the internet. Very important, very important. So I copy that. So the way we've been doing it, just IP access. Now we've been told to use extended. Then we paste that one and hit enter. Then permit allow FTP connection from FTP connections from PCB public address to DNS server. Okay, then deny all other FTP connection from internet to R2 LANs. Deny all SSH connection to this one. Allow all types of connection. Okay, so let's start with the part A. Permit TCP host PCB, which is PCB, which was IP address of PCB was PCB to access host. Which host? DNS server. Yes, the DNS server with the IP address of I'll copy the IP address of DNS server here. Copy that one, and then what else? Let me query. EQ FTP. Good. All right. Okay, now deny all other FTP connection from the internet to R2 LANs. What do we do? Deny TCP any equation EQ FTP. Good. And then deny all SSH connection from the internet. Okay, deny TCP any, then any EQ SSH is port number 22. Good. Then permit all other types of connection. Permit IP any. Okay, I think that's okay. I think this is okay. I believe so. You should consist 4 statements that correspond to 4 requirements above. Let me check if I have 4 statements. 1 2 3 4. Good. So apply access control list. Where do you on which interface do you apply all these access control list? Okay, let me check. Just check on router 2. So which interface do you apply these? Because we need PCB to access this one. Okay, so I think we can apply this one. It's here because we're using router 2. We're using router 2, so we can apply them to gig 000. It's quite challenging. So exit interface gig 000 IP access group. The group was just a minute. This one. This was the group. Okay, in, right? Then IP NAT inside. Exit and do right. This was a very long assignment task. That was a very long task. Let me check again. We are using which router? Are you using router 2. Just a minute. IP access group in, then IP NAT outside, not inside. Sorry. In IP NAT outside. Good. Do right. Exit. Good. So guys, we proceed to step 6. Configure access control on switch 3 to create a standard this one to allow PCs. Good. This is what we just turn over and over again. So I'll copy that one and move to switch 3. What I do, inspect rear. Here switch 3, inspect rear. I move this one, I place here. Okay, sorry, terminal, that one there. Enable config T. Okay, IP access, this one. Okay, sorry. IP access list standard, then place that one. Okay, to allow PCC, okay, to connect to S3 VTY interface. Okay, that's no problem. PCC as a IP address of this one, so I'll copy permit host, that one. Okay, all right, so line VTY 0 to 15, line VTY 0 to 15. What do you do? IP access class, we paste that. No, not this one, but the named access control list, paste in, sorry, in, exit, do right. So we're done there. Let's proceed to part 5, perform configuration backup and iOS update. Use TFTP server to backup device configuration. Backup running configuration of R1 switch 1, switch 2 to the TFTP server B. That's very easy, guys. Okay, so we start from R1. So sorry, which one is this one? This was switch 3. So it was about configuring access control list. Okay, that's okay. So it's R1, switch 1 and switch 2, but we are currently on switch 3, which is not applicable at all. So we start from R1, inspect rear, then switch 3, inspect rear, we remove it here, place there, good. Then we come to PC, okay, Cisco pass, enable Cisco and pass, good. All right, so guys, copy. We need to copy the running configuration to TFTP server. Copy, run TFTP, okay, and address of the host. We've been told to use PCB. So PCB is just a minute, this one. Okay, PCB is that one. Sorry, just a minute, this one. I paste that one here, and destination file name, so just say R1 running config, good. Waiting to write, it's copied, that's a success. Alright, so do write, so write. So we move to sorry guys, I've made a mistake. Name the configuration file as run r1 run. I'll modify, so let me just come here again and repeat the same statement that I've just done right now. Copy, then it was 192.168.1.5, then I paste that and hit enter. Good. So do that, everything's okay. We move to switch 1 now. Here switch 1, move and place here. Okay, and we repeat the same statement. Now let me copy how I'll do it. I've copied that, then I come here, terminal, okay, enable, then copy, run tftp to tftp 192.168.1.5. we want the name to be switch 1 run config. Let's wait. Okay, do right, I mean. So let's move to switch 2 very first. Inspect rear, move here and place there. Okay, so switch 2. Enable, copy, run to tftp. IP address of PCB is 192.168.1.5 and you want it to be switch 2 run config. Copy, let's wait and write. Good, so we're done there. So what's remaining is to step 2 now. Use TFTP server to update and upgrade iOS. Obtain the newer version, the newer iOS image from TFTP service on web DNS server. This is quite challenging, you know. Alright, the new version of the switch, this one configures to use the new version of okay. So this is quite challenging, but we have to go through it. Okay, obtain a new version of image from it on. Okay, so we use switch 3. Just a minute here. So we use switch 3. We've been told to obtain the new version of iOS image from TFTP server. Okay, so what I'll do, okay, I think I will remember something. Exit, copy, TFTP to flash. Yes, to flash. Hostname, we need DNS server. The DNS server is I'll copy the IP address of DNS server, which is this one. Copy, and paste. Okay, source file name. So we've been told to use this one as the source file name. Copy and I paste. Okay, destination file name. So destination file name should be, so you just hit enter and let it access it, and as you can see, it's successful. So guys, basically what's remaining is to configure SC to use this new version of IS after reloading. Okay, that's very easy. So click it. Okay, so let's configure that very first. Config. Okay, so boot system flash. Okay, then good, do right. So I think we are almost done. So what you need to do is to configure to use them on after reloading. So do right, then do reload. Yes. Okay, and as you can see, it's using the one that you've just used from the task. So guys, basically I think we have implemented everything as per the requirement, and I believe if we can submit this task now, we will get good marks. So I'll do that very fast. Submit assessment. So unfortunately we've gotten just 79, which is not that much bad, you know. Okay guys, so please subscribe to my channel, and let's see you again in the next project.